I am Pang Sinan. I am from College Dato Patinggi Abang Haji Abdullah, Kuching, Sarawak. I am a super teacher for physics. I have been teaching for about 23 years, and out of the 23 years, about 22 years, I have been teaching physics non-stop. And in my teaching career, innovative teaching is my passion. So that's the reason why you will see a lot of innovation in my teaching approach. But coming back to today's lesson, basically I am using two learning theories. The first one is the constructivist approach. The second learning theory that I'm using is the cognitive approach, but there are so many sections or so many aspects in the cognitive approach. I'm using two of the approaches, namely to say the inquiry and the discovery method of learning. So in every section of my lesson today, you will find that I am incorporating many of these theories inside. And a part of this, you will see a common grain all along my lesson, that there is an innovative element in it all the way. And in fact, I am also encouraging my students to have higher order thinking skills in the lesson, in the learning approach. And apart from that, you will find that contextual learning is also very heavy in the approaches that I take. So I'm using all this all into one lesson, the lesson that you are going to see. And in the introduction, you will notice that I am using contextual learning. The pen is something that is so common, every person on the face of this earth uses it. And I'm using the pen as the learning object, as the introduction, and as part of the instrument, the learning aid, the process of learning, all within this simple pen. Good morning, class.
Good morning, Uncle.
Yeah, be seated, please.
Thank you, Uncle.
How do you feel today?
Fine.
Very good. Okay, I'm sure that this morning the lesson will be exciting. There are some great things that I would like to teach you this morning. Let us see what it is. I'm going to teach you some concepts that will require you to remember what you have learned before. But this is something new. It is not in any textbooks or any reference books. So I'm going to teach you a new creative method to determine K, the spring constant of the spring in a pen. It's a new method. Let us see what it requires. Now before that, some months ago I read a very interesting article in the newspaper. Anybody read this article from the Star? Show of hands, please. Uh-oh. All right. It's good to be reading the papers more often, isn't it? Now, in fact, for anything below 10 English pounds, the ballpoint pen, it is the best invention of all time. And it is so significant that this morning we are going to use the ballpoint pen in our physics lesson. Now, what are we going to do? What I would like you to do is take a look at this spring. It is actually taken out from the ballpoint pen. Now, why don't we do it? All right. Now, you have your ballpoint pens with you? Yes. Yeah? All right. Now, take out the spring. Have a look at it. Yeah, just do that. Okay. Now, in science, we observe, we carry out experiments, and we think. All right, that is the whole gist about physics. It's a thinking subject, not a subject for memory. Now, in teaching, prior knowledge is such an important and key factor in the success of the lesson. And you will notice that right after the induction set, I went to ascertain the prior knowledge of the students. And in this particular section of my lesson, I found that I was using, again, two of the learning theories. The constructivism approach. It was so important. For example, I asked the kids to take the spring out. And I was asking them what they have been doing to determine the value of K. And they could tell me Hooke's law, F equals to Kx. Very good. So that was their prior knowledge. And basically, I was using constructivism to build on this, but not taking the spring out. It requires a higher order thinking skill to be able to do what I require them to do, but they have to make use of their prior knowledge. Now take a look at this spring. You have already studied how to determine the spring constant of a spring, isn't it? Some months ago. Now would anybody like to describe to us again how you do it? Okay, what about Stevie?
Using Hooke's law, which F equals to kx.
All right, thanks. Okay, very good, Stevie. F equals to kx, Hooke's law. All right, let's take a look. Okay, let us see. What is F? What is k? What is x? A quick review. Okay, FIZIK?
Force.
Force, okay, very good. And what is x then? Anybody? I'm sure you know. Now, Fa, what about you?
The elongation of the spring, force which make the spring long.
All right, but then this spring, this is the spring in the ballpoint pen. Do we compress it or do we extend it? Compress, okay. So what would be x in this case? Irma, would you like to try?
The length of compression.
Okay, very good. The length of compression or the distance of compression. All right, from this distance, we compress it. All right, so the distance of compression is x. And from there, we can calculate k. And what is k? Basri, what is k?
Constant of the spring.
Very good. Okay, please be seated. Basri, yeah. This is the spring constant. Excellent. Now, so this is the backdrop of our whole experiment. So you might be saying, Uncle, what is so great about your experiment? We already know what, right? But look at this. Today I have a difficult or rather a challenging job for you all to do. That is, I would like you to determine the spring constant of the pen spring, but there are three conditions. The first condition is that students are not allowed to take out the spring in the pen. So I'm going to put it back. You cannot take it out. Okay? And secondly, students are not allowed to use slotted weights because that is what you have been doing all this while in school. And lastly, you are not allowed to press this pen against the electronic balance directly to measure the force. I know you are smart, you want to measure the force, but you are not allowed to do these three things. So, you still have to find out what K is. Experimentally, you have the pens, take any pen as a sample, carry out an experiment, and find out the value of K. Alright? Now, by doing so, what I'm actually asking you to do is to think of all the concepts that you have learned. And after that, carry it out, use all the concepts to find K. Alright? Take 10 minutes now, describe or rather discuss what you are going to do. You look to the side of the table, there are some apparatus there, you can use the apparatus for your experiment. If there's anything else you need, you can let me know. But remember, these are the three conditions that I've laid out, three things that you are not supposed to do. This will force you to think very hard. I'll walk around and see how you are doing and I'll help you along. Alright, let's be doing that.
And the time measured by the stopwatch.
Using the stopwatch.
You're going to use stopwatch to measure the time. Alright. Now, okay, you show it to me again what you did. What you did just now.
Press the pen,
Alright.
and like that.
Okay. Very good try. I have purposed in my heart to let the students try out on their own. Completely unguided inquiry, doing anything they like, but they must solve the problem that I have given to them. And so they were using the inquiry method, being unguided, one of Sushman's inquiry method. So that was very good. But I have also planned beforehand, knowing that they would not be able to do that all the time, just trying to inquire and spending 2 hours on it. So I have decided to let them have some form of guided inquiry. All right, boys and girls, let us get back to our seats. Let me explain a few things. Now take a look at this. In my lesson today, I'm trying to help you to correlate something, to remember all the things that you have learned so far. For example, you take a look at the screen, Hooke's law. We have already discussed that. Yes. Now secondly, you take a look again, what do we have? Gravitational potential energy, elastic potential energy, principle of conservation of energy. We have studied all this. Now just let me know, just now I did not seem to observe any group doing this. Taking the pen, pressing it, releasing it, and let it fly up. Now that is the gist of the whole experiment this morning. Alright, let us just run through it. Now when I compress the spring, what happens? What energy is stored? Anyone?
Elastic.
I seem to hear kinetic energy. Now remember, when I compress the spring, press the spring, press the spring. Now what kind of energy is stored?
Elastic potential.
Okay, alright, everybody understands. When I release the pen, it flies up. So what happens? What is happening to all the elastic potential energy? The elastic potential energy is changed to gravitational potential energy. But then as it goes up, what is happening to it? Alright, let me just exaggerate the motion of the pen. I press it and then it moves up. Zoom. It goes up, okay? Alright, now as it is moving up, what energy is there? Very good, isn't it? Kinetic energy, isn't it?
Yes.
But when it reaches the highest point,
It change.
is there any more kinetic energy?
No.
No more. Alright? So what can you say? Give a conclusion of the whole story when it reaches the highest point. Very good. The elastic potential energy, all of it is changed to gravitational potential energy. Okay, very good. But you have made an assumption by saying that. What is the assumption? Can anybody tell me what is your assumption when you say that all the elastic potential energy is changed to gravitational potential energy? It sounds very good, but you have made an assumption, which we do as scientists from time to time to study some theories, some laws. So what is the assumption that we have made, or that you have made? Now, Fauzan, say something. Energy quantity is the same. Alright, good try, but conservation of energy. Very good. Can you put it in another way? What do you mean by conservation of energy? Alright, somebody giving me the formula of half mv square. That is for kinetic energy, right?
Yeah.
Annie, you want to say something? All the energy has been changed from elastic potential energy to gravitational potential energy. But we have made an assumption. What is the assumption? We assume something. Alright, we cannot create or destroy energy in the system. Okay. Now, basically what you are trying to say is that we assume that there is no energy loss. But in real life, is there energy loss or not? There is. Okay. For example,
We work.
alright, friction. What else? When we do the experiment, do we hear anything? Yeah, sound energy. Alright, but we are saying that no energy is lost. That is an assumption. Alright, so you use that to try to solve the problem to get K. Can you do it? Alright, you want to try it. Alright, so you try it and relate all this on the board then you will be able to do it. So now for the next 20 minutes, you do the experiment on only one of the pens. Just use one of the pens in your group. Decide what pen it is, which pen it is, and then you do it from beginning to end and come out with the value of K. And after that, we discuss the results. Okay, you're on your own now for the next 20 minutes. The force that you press is not the great idea.
29.
Now we come to the section of the lesson whereby the students were spending about 20 to 25 minutes on their own trying to determine K, especially with the alternative that I have proposed to them. Nevertheless, I have not taken the recipe approach. Give them a handout, 1, 2, 3, 4, 5, just do everything. No, that wasn't my approach. In fact, what I did was, I preferred the student-centered approach. That was what I did. And I knew that the students, every group, they were different learning abilities, so I could not treat them the same way as a homogeneous group. That was the reason why I had to go from group to group and probe and help them, ask them leading questions, guiding them to doing the experiment. Okay, so far so good. All right, may I have your attention now, please? All right, can you kindly get back to your seats again? Yeah. Yeah, let's get back to our seats. I'll try to explain something on the screen. All right, so maybe this will block you. We can put it down. Now let me explain something on the screen now. Now actually, I'm very pleased with all that you have done. And as you discover step by step, you get it, and then many of you so excited, you just say, oh, it's like that, you know, and then suddenly you see something new in physics, isn't it? All right. Now, I noticed that some of you, you went to take the mass of the pen, right? So it depending on the mass of your pen, you get the values. And then some of you, you took the value of the length of the pen before you compress it. And then after that, some of you, you continue with the experiment, you took the length of the pen after you have compressed it. And then you let it fly up. And when you let it fly up, you get the value of H. All right? But then we need to tie up all this, isn't it? Okay, all these things that you are doing, we need to tie it up. And over here, I actually have one group of students that have done this before, and these are the readings that they have obtained. All right, very quickly we look at the readings. But now to tie up the whole picture, what are we going to do? It has to be very clear. And I'm very sure that almost all of you have got it. Let's take a look at this picture. Now remember that this pen, after it has been compressed, we release it, it flies up. And when it flies up, there is a distance h that it has moved up. And that is the h value that you need to measure many times to get the average, right? That is h. And how does h tie up in the whole concept that we are doing? Let's take a look at the whole calculation, the concept, then you will get the picture. Because just now earlier I've explained how the change of energy, isn't it? Now we are going to put it all together using the example, the values that I have, and then we are going to calculate it, and then you will get the whole picture complete. All right? Now, for the pen that we have used it with another group of students, the mass of the pen is 11.5 grams. All right? Perhaps you can take this down as an example. And the length of the pen before we compress it is 14.4 cm. We can call it L0. And after that, we can call it L1. After compressing it, is 13.5 cm. So what do you think I'm trying to do? What do I want to get by having these two values? Yeah, the value of x, the distance of compression of the spring, isn't it? And so what is the value? Can anybody tell me? 0. Very good. So that is 0.9 cm. So it is step by step, we do it. And from the experiment, we have obtained that h is 7.5 cm in this instance. Can you read it from the back? Can you get it?
Yes.
All right. Now this is a very important statement in physics. Just now I mentioned it, now I'm mentioning it again. Assuming that there is no loss of energy, and when the pen has moved up to its highest point, what do we have? See, this is an important statement. And this is what we need to learn to do as young scientists, as young physicists. We say all the elastic potential energy is changed or converted to gravitational potential energy. Elastic potential energy, just now we discussed, all right, it is actually half Fx is the mathematical expression. It is equals to mgh. Many of the groups got it. Equals to mgh. So we call this the first equation. And from this, as we discussed just now, experimentally we can obtain h. G, we take it as 10 meter per second square. M is the mass of the pen, very good. And x is the distance of compression. So from this experiment, we obtain f. That is the whole idea. We want to get f. And after that, what do we use the value of f in? Another equation. What is the other equation? F equals to? That is an application of one of the laws. What law is that? Hooke's law. Very good. All right. So from Hooke's law, we know that f equals to kx. And by solving these two equations simultaneously, we get the value of k. So in this particular instance, we have k equals to 213 Newton per meter. All right. Now to save time, what I'm going to do is this. Later on when I give you a worksheet, I will go around and see your own values. Because every group has your own pen, right? Okay, you can call that, perhaps you can call that pen number 1 following the group, pen 2, 3, 4, pen number 5, pen number 6. You label it that way, and then you can put that down in your worksheet as the extra value of your own pen. Alright, if you are group 6, you just put pen number 6. Alright, because there are some other values that I've given to you, I would like you to work it out. Alright, now any questions so far?
No.
Is this clear or not?
Yes.
Yeah. So you see, it is step by step that I've guided you by giving you leading questions right from the top till now. Alright? And after that, I had to reinforce their understanding of this whole concept of determining k. And I gave them a worksheet. And they had to do the worksheet in class. Some of them couldn't complete. They had to do it at home. And this whole section has to do with mastery learning as well. So what I would like you to do is, the group leader from each group, you just come out here and take the number of copies that you need for your group members. Spend the next 10 minutes answering the questions on the worksheet. Alright, let us just do that. The group leaders, please come forward. Yeah. Alright. So far so good, isn't it? Excellent. Yeah. In my closure with the students, basically we just saw how we determine the value of k, and everybody understood it. But then I reminded the students that I put 3 constraints on them, 3 conditions imposed on them, 3 things that they were not supposed to do. Now why did I have to do that? Basically, I would like my students to be able to think, especially using higher order thinking skills, innovative thinking skills, so that they can apply their knowledge, so that they can analyze, so that they can synthesize, so that they can evaluate. These are all higher order thinking skills. So in short, in the whole of my lesson, I have actually used 5 main aspects of learning and teaching. Number 1, I have made use of innovative teaching. Number 2, constructivism. Number 3, inquiry discovery way of learning. Number 4, higher order thinking skills. And number 5, contextual learning. All right, very good. You are trying very hard. Now let us just recap and have a look at your answers to the worksheet and just get some final points, what we have been doing all this while. So to summarize some of the things that you have done, all right, and some of the things that you have done, let's take a look at one of the video clips. This is what you did just now, isn't it? Right? That's what you did just now. All right? It's fun, isn't it? That's exactly what you're doing. But you need to take many readings, right? Very good. So after we have done all that, and then this is part of your worksheet, right? This is exactly what you have in your worksheet, and I've asked you to try to work out the problems. Alright, now as you compare your own results, now I don't expect all of you to get it very fast because of short of time. You can go back and complete it. You can also go back home and complete your laboratory report before you hand it back to me early next week on Monday. Alright, now after you have done all this, you would be getting results something like this. This will be your results. And take note of the units in SI form. Alright, it must be SI units. And in this experiment, what was one of our assumptions that we made? When we let the pen be compressed, we let it fly up. Alright, we had one assumption. I want to state it again, it is so important. Anyone wants to try? Anybody? Yes, okay, Teresa. Sorry? Very good, Teresa. There is no loss of energy in our calculation. That was the assumption that we have to make. So that we need to make some assumptions, otherwise we cannot do any of the calculations. We can't proceed, isn't it? Very good. And so, all the elastic potential energy, after we have compressed it, what happens to it when it reaches the highest point? Okay, put up your hand. All right, Regina?
Elastic potential energy changed to gravitational potential energy.
Okay, perfect answer. All right, loud and clear, we heard it. Okay, very good. All of you heard the answer, isn't it? So basically, that's it. And we made use of all these four principles, these principles and laws. We correlate it. We have two equations. We solved it simultaneously. And hey, presto, we came out with K. Alright, so with this, I would come to a close in the lesson, and I would like to say that I've enjoyed myself. I hope you have enjoyed yourselves too, and I would say thank you very much, and may God bless you. Yeah, okay, thank you, class. Right, please be seated. Yeah.